Hello students, let us solve the question from mechanical properties of matter. So the question is identify the correct answer. When a wire is stretched to double its length, then a stretch is equal to Young modulus, strain is equal to 1, radius is half, and Young modulus is twice of elastic deformation energy density. So we have to choose the correct answer. So this question is from mechanical properties of matter. So let us draw a wire of length L. So let us draw a wire. This is a wire of length L of radius R1 and this length is L. So this wire is stretched to double its length. So this is again stretched to length L. This wire is again stretched to length L. So delta L equals to L and total length of the wire is 2L. Total length of the wire is twice of L. So first of all, calculate the strain. We have to check the strain. So strain is change in length divided by original length. So change in length delta L by L. Change in length divided by original length. So change in length is L. This is L. Since it is stretched to length L, so delta L is L and original length is also L. So this becomes 1. So strain is equals to 1. So second statement, B option is correct. The strain of this wire is 1. Now let us calculate the stress. Since Young modulus is Young modulus Y is given by stress divided by strain. So from here we can calculate stress is Young modulus times strain. Now strain is equals to 1, so stress will become equal to Young modulus. So stress will be equals to Young modulus. So stress is equals to Young modulus. This option is also correct. Now we have to check the radius when it is stretched to length L. So initially the wire has length L and radius R1, and final length of the wire is twice of L, and let us suppose the radius is R2. So volume does not change. So initial volume of the wire, volume initial is equals to volume final. Let us suppose that the area of cross section initially is A1 and after area of cross section is A2. So initial volume will be A1 into L1. So initial volume will be A1 into L1, which will be equal to A2 into L2. So A1 is pi R1 square. L1 is L. L1 is initial length of the wire, which is L. So area A2 is pi R2 square, and L2 is of length of the wire after stretching. So length of the wire after stretching is twice of L. So now pi will be cancelled. We have to calculate the R2. So R2 square will be equal to R1 square L divided by twice of L. So L will be cancelled out. We get R1 square divided by 2. So radius of the wire after stretching will be R2 will be 1 by root 2 times R1. So this is the radius of the wire after stretching. So radius of the wire after stretching is not half, rather it is 1 by root 2 times initial radius. So this statement is not correct. Now we have to check the elastic deformation energy density. So elastic deformation energy U is half of stress into strain. Stress into strain. Since stress is Young modulus time strain, we can write half of Young modulus time strain, and strain into strain will be strain square. Now we have calculated the strain is equals to 1. We substitute strain equals to 1, we get U equals to y by 2. From here we can calculate Young modulus twice of energy. So Young modulus is twice of elastic deformation energy. So this statement is also correct. So A, B and D are correct. So which option is correct answer? A, B and D. Option 4 is the correct answer. Hope you find the solution understandable. Thank you.